Okay, hello everybody. Am I audible? I hope that I am audible to you guys. Please give a thumb if you can hear me very clearly. Hello everybody. Am I audible? So it's perfectly fine from my side, but yeah, still if you have any you can say difficulty in audio and video, please let me know, guys. So due to some technical glitch, there is a interruption in the class. Okay, and sorry for that, guys. Now we will continue our class. Yeah, I hope that you guys are watching me live, guys. You guys are watching me live? Yes, please give a thumbs up. Yeah, Mohammed. So actually we were discussing the thermodynamics actually, right? So we were discussing this word thermodynamics. Okay. Okay. So we were discussing, guys, this word thermodynamics. So as I told you earlier that what is the meaning of thermo? Thermo is related to the heat, okay, and dynamics means particle in motion. Dynamics is basically stands for something which is in the motion, right? Is it clear to you? So in the particularly in the thermodynamics, we will basically deal with the gases. So here for the particular gases, we use a word that is a particle in motion, right? So basically I can give a statement, or you can say definition of the thermodynamics is that it is the branch of science which deals with the heat and its relation to energy, work, and the changes occurring in a system due to motion of particles, right? So what I'm saying, what is the meaning of thermodynamics? That it is the branch of science which deals with the heat and its relations to the energy, work, and changes occurring in the system due to the motion of the particle. Here is a word that is called system. Here is a word that is called the system, right? So first we have to understand what is the meaning of the system. Okay. Now, I hope that this is clear to you, right? Okay. So before understanding the system, I can give you the another definition of the thermodynamics, which is similar to the above. I can say that thermodynamics may also termed as energy conversion as in this maybe heat is converted into the work or vice versa, right? So in the thermodynamics, basically we see the interaction between the energies. We basically see the interaction between the heat and work. In some cases we convert the heat into the work, or in some cases we convert the work into the heat. So in the thermodynamics, basically we studied the energy interactions, right? Heat is also energy, work is also energy. So basically in thermodynamics we see the interaction between the energy. Now here this is a word, system. What is the meaning of system? System is nothing but it is the portion of anything. This is any portion of anything which is under observation, right? So whatever is under our observation, that is called the system. That is called the system, right? Except that whatever is the surrounding of that particular system, that is called surrounding, right? Let's suppose in this picture, let's suppose this is the area which is our under observation, which is under our observation. What is the meaning of under observation? That what is the meaning of under observation? Under observation means that we are interested to see the energy interactions for this particular area, right? Whatever is happening other than this is not our concern. Our concern is only to study that what are the energy interaction, what are the changes in this particular part due to the motion of the particles. That is called my system, guys. That is called my system, right? Okay, other than this, whatever is the surrounding, that is called the whatever is surrounding, like this area is called surrounding. This area is basically called surrounding, right? And a imaginary separation is there, a imaginary boundary line is there which separate the system from the surrounding. So whatever you see here, that this line, this boundary, this is basically nothing but it is an imaginary, guys, right? It is the imaginary line. This is my system boundaries. What is this? This is my system boundaries. I hope that this is clear to you. So this is my system and this is my surrounding. This is my surrounding and these are the system surrounding. These are the system boundaries, right? So there is, you can say there is no any physical significance of this boundary. This is the imaginary separation basically. I hope that this is clear to you. So this part is only our under observation. Okay, is it clear to you? Now if we add everything, if we add system plus surrounding, if we consider everything, this is a system plus surrounding, that is called universe, guys. That is called universe. I hope that this is clear to you. I hope that this is clear to you, right? So this is the basically meaning of system. This is the basically meaning of system, right? So I can, you can say, make a statement from this concept that we consider a system which is under our observation, right? Having boundaries and occupying some space, right? Is it clear to you? Okay, whatever the interaction is this of the heat and work, whatever is the interaction is there between heat and work, that is basically interaction between the surrounding and the system. Is it clear to you? Whatever we see the interaction between the energies, that is between the system and the surrounding. Is it clear to you? Right? This is called my thermodynamic system, right? So everything around the system is surrounding. Everything around the system is surrounding. So I can say that my universe, what is my universe? Everything is universe means system plus surrounding. System plus surrounding is my universe. Okay. Is it clear to you guys? Mohammed, this is clear to you? I hope that I am very clear about this. If you have any problem, if you have face any difficulty to understand anything, you can tell me. So write all the things which is written here. Okay. So in this particular slide, we can say that, okay, whatever is basically under our observation, that is the system. And we are studying thermodynamics, in which we are basically seeing the interaction between the energies. Interaction between the energies is basically between the system and surrounding. If I add system and surrounding, that whole thing is called universe. That's it, nothing else. Okay. Now we have to study the different types of the system. So you can make a heading, classification of the system. Please make a heading, classification of the system. What are the different types of the system? Okay. So guys, roughly there are three types of the system. One is mine, you can say the closed system. Second is my open system. And third is my isolated system. Right? There are three types of the system: closed system, open system, and the isolated system. So what is the meaning of closed system, open system, and isolated system? Let's see. Let's see this, guys. So in a question, in a particular theory, that if a question statement is like, okay, we have an open system like this, we have a closed system like this, so we should know about this. What is the meaning of closed system and what is the meaning of open system? For open system, there are different concepts. For the closed system, there are different concepts. For isolated system, there are different concepts. Okay? ठीक है. Let's discuss, guys. First of all, closed system. Please put a heading, closed system. Closed system. Okay. To understand the closed system, let's make a diagram so it is easy for us to understand the concept. Closed system is also known as the known flow system. It is also called known flow system. Right? Okay. Let's suppose, guys, we have a cylinder piston arrangement. Let's suppose we have a cylinder piston arrangement. Okay. What is this arrangement? It is something like that. Let's suppose that initially the position of the piston is this. This is your piston. Okay. This is any crankshaft which is attached to the piston. Right? Okay. And these are the gas molecules. Just try to understand it. Okay. Just try to understand it. Now, first of all, we have to decide that what is the system, because we are not here to study the universe, guys. We are here to study a system, a particular system. So for that purpose, we have basically select some specific boundary. Okay. And after that, we see the interaction of the system to the surrounding. That's it. So I want to see the behavior of the gases when I heat this gas. Okay, so let's suppose this is my area of under observation. This is my area of observation. Okay, this piston, this gas, and like that. This is my system boundaries, guys. This dashed line is my system boundaries. I'm giving heat to this system. I'm giving the heat to this system, right? Okay, so as you can see that if we are heating this cylinder pistons, cylinder gas system, this gas is basically going to expand, right? If this gas is basically going to expand, then this your piston basically move in this direction, right? Is it clear to you? So due to the expansion of the gas, I hope that you know this, then when we basically supply the heat to the gas is basically going to expand, right? The intermolecular distance between the molecules is basically going to increase, right? And these molecules applying, you can say, the force on this, you can say the piston, and piston is going up, going basically in this forward direction. Let's suppose the final, let's suppose this is the initial position. The final position of the piston is like this, right? And the gas molecules are here. Now this is basically, you can say, my second position. This is my final position, right? And this is my gas molecules. I hope that whatever I say here, you understood my all points. Now see, we are studying the closed system. Okay, so here see, this is my heat. I supply the heat to the system. What I'm getting, guys, by heating this, you can say this gas, I'm getting some work. Is it clear to you or not? This piston is basically going in the forward direction. It is in the upward direction, right? In this direction, right? So I'm getting some work. So basically here, heat is converted into the work. How much heat is converted into the work, we are not discussing here. We will discuss this by how much fraction and Planck, whatever it is, we will basically discuss it later. Yeah, but some part of the heat is converted into the work. That's why this piston is basically move in the right direction. Okay, is it clear to you? Now, I explain whole process. Now, I'm expecting from you guys that you can help me in the observation. My first observation, tell me if I'm wrong, my first observation is like that heat is basically crosses the boundary. This is my system boundary, and through this system boundary, my heat is crossing the system boundary, yes or no? So I can make a first statement that heat crosses the system boundary. Yes or no? Yeah, Muhammad, please let me know that this is clear to you or not. Okay, is it clear to you? Second statement. See, the piston is moving in this direction, and this is my system boundaries. So also work is crosses the boundaries. Work is also crosses the system boundaries. These are my two observations. I hope that there is no issue in that. If you have an issue, please let me know. My third observation is something like, see, this is my system boundaries. This is my system boundaries. It means we are going to study this portion only. That whatever the change, we will see the change here only. But as you can see here, guys, that this piston is moving here, right? Now we have to study this much portion. Yes or no? Now we have to study this much portion. So we can say that system boundaries are not fixed. Yes. So I can say that system boundaries are not fixed. are not fixed. Okay, is it clear to you? Now, fourth point. What is the fourth point? See, I think you are agree with me that there is no any gas flow from system to surrounding. Yes or no? There is no leakage of the gas. Whatever the mass of the gas is there, the mass of the gas will be remains constant. Yes or no? So there is no gas in, no gas out. There is no flow of the gas here. That's why it is called known flow process. That's why it is called known flow process. Yes or no? So I can say that the mass, this point is important. Okay, mass of the gas remains fixed. Remains fixed. I hope that this is clear to you. Yes, that I can say that no gas in, no gas out. Can I make this statement? Yeah, Muhammad, please let me know. Can I make this statement? That mass of the gas remains constant. Means there is no mass transfer actually. Right? So we can say that as nothing goes in and nothing goes out, it is called the known flow process. Okay? That's why it is called the known flow process. Okay? Is it clear to you? Right? Now, if I'm making a single statement, then I can say that in the closed system, I can say this point is important actually. Fifth point, there are two things, mass and energy. Now I have to see that is there mass transfer is there or not, or energy transfer is there or not. So as I can say that there is a no mass transfer actually. No mass transfer, right? Whatever the gas is there in the before condition, after expansion, the mass of the gas will be basically remains constant, right? Yeah, energy transfer is there. Energy transfer is there. As you can see that heat crosses the boundary, work crosses the boundary, heat converted into the work, right? But the energy transfer is there. Energy transfer is there. So this is basically your closed system. So important point is that in the closed system is called non-flow system. If you remember the name actually, then by name itself this is clear that there is no mass transfer at all. That's why it is called non-flow system. No? So in the closed system there is a no mass transfer, but energy transfer is there. Energy transfer is there. Is it clear to you? And these are the other points. You can remember all these points. If you are okay with it, you can tell me. After that we will move forward. In the similar way, we'll try to understand the closed open system. Okay, in the similar way we will try to understand the open system. This is clear to you? This is clear to you guys? So today the class is very basic, you can say. We just trying to familiar with the thermodynamics subject. We basically try to discuss the, you can say the simple terminologies actually which we used later. Okay. Okay. So yeah. Okay, so this is my closed system now just okay, great. If you have any problem guys, if anybody's have any problem, you can ask. Okay, you can ask. Now my second system is open system. Open system. Okay, what is the open system? Just we will try to explain this with the help of compressor. Okay, what is the compressor? Compressor is basically you can say a device which is basically used to compress the gas. ओके जब आप PSU में काम करेंगे तो आपको बहुत बड़े बड़े कमरे की साइज जितने कंप्रेसर आपको दिखाई देंगे. ओके so let me make the diagram of the compressor, that what is the compressor. So in the compressor, basically what is the main funda? Main funda is basically to compress the gas, right? This is the main funda of the compressor, nothing else. So this is the basically area for the inlet, and this is the compressed gas. So let's suppose this is the receiver. This is my receiver, okay, and from this receiver we are receiving the gas. Also there is, this is the, you can say, the piston which is going to compress the gas, right? Is it clear to you? Okay, so there should be a fins for the heat transfer. Okay, so this is the fins installed for the heat transfer, right? Now to start this your compressor, there should be a, you can say, motor. So this is the motor actually, right? Okay, and let's suppose this is your crank shaft. Right, this is your atmospheric air in. Okay, is it clear to you? And after compressing it, it is the high pressure air which is going here. This is my high pressure air. Done. Okay, okay, I hope that this is clear to you. Now let's understand this. So this hole is my what? This hole is my, guys, your compressor. Okay, so what is the basic funda of the compressor? Basic funda of the compressor is atmospheric air is basically going into this compressor, and it is compressed through this piston, and when it is released, it is going through this in this direction, and we are getting the compressed air here. We are getting the compressed air here, right? Is it clear to you? In the compression process, there is a heat, there is a release of heat actually. There is a, in the compression process, your heat is released actually. So first of all, let's make the system boundaries. Let's make the system boundaries, right? So system boundaries, what? The boundaries which is basically the thing, or you can say the space which is under our observation. So this whole compressor is under our observation, right? So this whole compressor is my under observation, right? So these dashed lines are my system boundaries. Now in a similar way, I will try to see that what is basically crosses the boundaries actually, right? Is it clear to you? Okay, open system. Open system is also called, like closed system is called non-flow, open system is called flow system. Why it is called flow system? I will tell you. I'll tell you, don't worry. Flow system, open system or flow system, right? Now see, first of all, let's understand this. This basically motor, this motor is basically what is going to do this motor? This basically going to basically you can say moving this crankshaft so that this piston is going into in this direction and it compress the air, right? So this motor supplies the work. This motor basically supplies the work, yes or no, guys? Yeah, okay. Now in this compression process, there is a basically you can say heat generation due to friction and all that, right? So for the heat transfer purpose, we installed the fins here. Through these fins, heat transfer is there. So heat is basically transferred through these fins, yes or no? So there are two statements I can directly observe. First statement is that, see, work is also crosses the boundary, heat is also crosses the boundary, yes or no? So those 2 points are similar. I can say work crosses the boundary. Yeah, Mohammed, you have any doubt? And heat is also crosses the boundaries, guys. Okay, these 2 points are similar. Okay, is it clear to you? Okay. I hope that this is clear to you. Now, third point I can make for this, that see, here you can say that system boundaries are fixed, guys. Yes or no? Here it is not moving. Like in the previous case, my system boundaries are not fixed. But here my system boundaries are fixed. My system boundaries are fixed, guys. I hope that this is clear to you. Okay. Now, fourth point. What is my fourth point? See, please tell me that there is a energy transfer or not. There is energy transfer or not. Tell me, please. Is there any energy transfer in this process or not? Is there any energy transfer? Is there any energy transfer in this process or not? Please let me know. Please let me know. Yes, Mohammed. Can you make the statement about the energy transfer? Energy transfer is there or not? Energy transfer is there or not? Or you can say heat transfer is not, heat transfer is there or not? Obviously heat transfer is there, right? Obviously heat transfer is there. What about the mass transfer? What about the mass transfer? So see, yeah, in this system mass transfer is also there. The gas, the mass of the gas is not fixed here. Is it clear to you? Here mass of the system crosses the system boundary. Here at the inlet also, and also that we are getting the compressed here, that is also leaving the system boundary. So at the inlet and the outlet, we are having the basically mass transfer is there. So mass transfer is also there. Mass transfer is also there, right? Because the mass transfer is there, this system is called flow system, right? So in the closed system, there is only heat transfer, no mass transfer. In the open system or flow system, heat transfer as well as mass transfer is there. That's why it is called the flow system. Okay, is it clear to you? Okay, done. I hope that everybody making the notes parallelly. So in the closed system, right? Okay. So let's take an example and tell me that the system is open system, closed system, or what? Okay. So let's take a example. Let's take a pressure cooker. Let's take a pressure cooker. Okay, so let's suppose we have a pressure cooker. Let's take a pressure cooker, guys. This is my pressure cooker and this is the vessel of the cooker. Okay, okay, is it clear to you? And whatever, there is some content into it. Okay, just analyze this system. Just analyze this system. So obviously we are giving the heat to my pressure cooker. I'm giving the heat to my pressure cooker. Okay, and my pressure cooker is my basically system. So if this is my system, then there is a system boundaries. So let's suppose this is my system boundaries. This is my system boundaries, right? And obviously we are giving the heat to the pressure cooker. So first of all, pressure cooker crosses the boundaries. Heat is basically crosses the system boundaries, right? Yes. So my first observation is something like that: heat is crossing the system boundaries, right? Okay, now see, I think it's nothing like that you are hitting, you can say just you put your cooker onto the gas and it is basically suddenly it is you can say your start to whistle. No. Yes, yes or no? ऐसा नहीं होता ना? It's nothing like that you just put your pressure cooker onto the gas and your whistle is going to whistle is basically blowing, going to start. Yes, is it? I think it's nothing like that. It is basically taking some time. It is basically taking some time, है ना? It is basically taking some time for the generation of the steam, and due to the pressure of the of that steam, my whistle is basically going to blow, right? So when there is no whistling in the cooker, in the pressure cooker, up to that my pressure cooker is a closed system, because there is no mass transfer. Only heat transfer is there. Only heat transfer is there. Only heat transfer is there. But once due to the stream pressure, when my whistle is basically whistling, then stream is basically crosses the boundaries, or you can say mass transfer is there. Mass transfer is there. After that, it is my open system. So before whistling, it is my closed system. After whistling, heat transfer is there. Also mass transfer is also there. That's why I can make a statement that this system is my open system. Is it clear to you? So just you can say we can make the statement like this. Yes, Mohammed, am I clear with this? Yes or no? Am I clear with this or no? Please see the initial 2 or you can say up to the 3 lectures very patiently, because in the initial lectures we are building the concept, you can say we are building the foundation which is important for the further subject, right? Is it clear to you? These are the very small things, okay? And these small things basically is your fundamentals. If your fundamentals is strong, you can solve any difficult question. If your fundamental is not strong, if you are taking so granted this information, then I can say that it's not going to work, guys. Okay, so initial 3 lectures are very important for any subject, because in the initial 3 lectures we are trying to give you the overall overview of the subject, that what is the subject, what is the importance of the subject, how we deal with the subject. Also, to understand the subject, there is a specific language, you can say, right, in which we discuss the small terminologies. Okay, we build that terminologies, and after that my foundation is builded. Now I can stand my tall building. There is no issue, right? After some lectures, I'm explaining directly, okay, this is my open system, this mass is transferring here and all that. So there is, if you know what is the meaning of open system, then there is no issue. Okay, and if you taking these information very granted, then you don't know about what is the meaning of the open system. Okay, so the initial lectures are very important. Okay, now my third system is isolated system. My third system is isolated system. As its name suggested, isolated means there is no any, you can say, interaction of the system, right? So let's suppose this is my system. This is my system, guys. Okay, and this is the system boundaries. This is my system boundaries. Okay, what is this? This is surrounding. This is my what? Surrounding. If there is no interaction between the surrounding and system, right, means there is no heat transfer, there is, you can say, no interaction of the work, system is not going to give the work to the surrounding and all that, means there is no interaction. So we can say that system which is completely uninfluenced by the surrounding, guys. Okay, I can make the statement that the system which completely uninfluenced by the surrounding is known as isolated system, right? There is basically no interaction at all between the system and surrounding. Is it clear to you? So we can say that in the isolated system, the system boundaries are so rigid that they do not allow the heat and work to pass through it, guys. Okay, we can say that the system boundaries are so rigid. System boundaries are so rigid that they do not allow the heat and work to pass through it. Is it clear to you? So if I'm saying, tell me one thing, this is the what kind of transfer is there? Heat transfer is there, or work transfer, heat transfer is there, or mass transfer is there, or you can say there is no transfer here, guys. Please let me know. Heat transfer is there or not? Mass transfer is there or not? Please let me know, so that I can make a statement. Heat transfer is there or not? Heat transfer is there or not? Mass transfer is there or not? Heat transfer is there or not? Mass transfer is there or not? Or only heat transfer is there? Yes, there is, you can say, no transfer here. There is no heat transfer at all. There is no mass transfer at all. Right? So in the isolated system, there is no heat transfer. There is no mass transfer. Okay. So let's revise, guys. Closed system, mass transfer or heat transfer. only heat transfer. Open system, both the transfer, HT and MT, both heat transfer and mass transfer. Isolated system, no heat transfer, no mass transfer. Okay, so these are the basically classification. These are the basically classification of the system: closed system, open system, and isolated system, right? And what are the transfers, what are the cases we basically discussed here, guys. Okay, so for today's, that's it from my side, guys. And in the next class we will discuss the further properties of the system, right? Intensive, extensive, intensive, and all that. After that we will explain the temperature and all that, temperature scale and all that. Okay, so I hope that you understood all the things, but still if you have any doubt, you can reach me. You can reach through the Telegram message. You have a group of the GATE 2027 thermodynamics. You can post your doubt here, and also you can ask me through the WhatsApp or anything you want. Okay, but yeah, again I'm saying, guys, just try to watch the lectures live. That is a very, you can say, the impactful way. That's a very, you can say, the efficiency of the lecture will be very high, right? Your mind will be active as compared to you are watching me in the recorded format. Okay, so yeah, this is it from my side, guys. I hope that you understood all the things. Okay, chaliye, thank you so much. Bye bye and take care. See you in the next lecture. Okay, bye bye, guys. Take care. And for the timings, please stick to this Telegram group. Okay, ठीक है, चलिए, okay, bye bye, guys.